All right, welcome everybody to our second Thursday. See, this week went really fast, I have to say. Can we just get some confirmation in the chat that everyone can hear and see me?
Yeah, it's all good.
All right, good. Now I know this is a weird day because you are obviously focusing on the test, but we do have to make some progress into the second half, so it's a little tricky. It's a little tricky, but we can do it. Where is my... Oh, here it is. Let's make a page. Let's zoom in on the page. Oops, too much zoom, too much. Back it up. There we go. Okay, so our main focus is chapters 9 to 11. 9 to 11. Are there any questions on these? Now, in the book, especially chapter 9, we do explain why the divisibility tests are what they are. Those are not test concepts. For the test, which is quiz 3 next Friday, you only have to know how to use the divisibility tests. So know what they are and use them, not explain why they are what they are. That is really just, it helps me, it makes me feel better if I know I've at least seen where this test comes from. It's not someone just made it up because they wanted to. There is a logic behind it, and I could go look it up if I don't remember it, but at least I've seen it once. So the divisibility tests go up to 11. We have to know what they are and how to use them, not why they are. Then, when it comes to prime numbers, we have to not necessarily especially here in significant results, that there are infinitely many prime numbers and so on. There's some discussion there. We don't have to know those proofs or know why those results are true, just that, just what are the prime numbers and how do I verify if an integer is a prime number or not? What do I test? How far do I test? Those basic concepts. You also don't need to worry about the section 10.5. That's just really for interest sake. I was so far down the rabbit hole, I thought I would just finish it because the test for 7 is so weird yet interesting. It extends to the other prime numbers as well. So I wanted to make a note of that, but it's certainly beyond any test question. Then for the common factors and multiples, we're very much, in concept at least, we're very much at an elementary school level where they would make lists of factors and find the greatest common factor. Lists of multiples, find the least common multiple. It's a very good starting strategy, but of course, when your numbers get big, then making those lists are very inefficient, and we can exploit the building blocks behind those numbers, which will be the prime numbers, to understand the greatest common factor and least common multiple much better. That was my little blurb. Now it is up to you. If all of you are obsessed with the test, we can certainly just talk about the test. It's totally up to you. It's your session. I do not care what you ask. But hopefully someone asks something.
I put some questions in like the text box. There's like a bunch of them that I asked if we could go over like similar ones.
Did I just not see them? The
I
only
guess
one I see is Dave saying hello.
Oh, maybe I put it in the. Oh, I put it in the general one.
Yeah, we are, because the only thing that's going to show on the YouTube video is the main classroom chat. So if you can copy and paste them over.
Let me just find it.
Can you copy and paste them over? I could do
Yeah.
it too, I guess. Yeah, you can do it. Yeah, I don't check the others. Those are sort of for after hours. All right, there we see something. Can we go over questions similar to 9.4, 10.1, 10.4? Are those problems or exercises? Problems, I'm
They were
guessing.
problems.
Problems 9.4. Where is that? 9.4. Yes, that is uh, that's sort of the heart of the divisibility chapter, right? Do I know my tests, and can I apply those tests for 2 to 11? So we could use these problems, or we could make our own. I'm just gonna make my own,
Hey,
maybe.
kind of piggyback on there.
Yeah, sure.
In exercise 9.4, it's basically the same question, but it says explain your answer each time. So explain your answer for each of those numbers. And I'm wondering, is that the mathematical language or?
No. You're just mentioning if you say it's not divisible, then because the divisibility test is this and it failed because of whatever, depending on the test. So it's just a very brief few words to indicate that your reasoning is by way of the divisibility test. So
Perfect.
nothing too fancy, no. So let's do one. I'm just gonna make up my own, maybe. Maybe that's better. Where's my pen? I should have a pen. That was problem 9.4. Whoops, 9.4. Problem? Was it? Yes. All right. Let's not make the number too big. Let's call the number n, so it's just a little easier. Let's go 54,703. Totally random. You should have made it up, actually. So now I'm going to test divisibility by 2, 3, 4, 5, 6. I'm never going to ask you 7 because 7 is tedious. I could just as well do the long division. There's no gain in that test. The test really should be uh, a time benefit, and sadly 7 doesn't want to play with the others. So it's going to be yes, no, yes, no, yes, no for each, and then my reasoning, just briefly explaining to show, do I know the test? What am I even looking at here? Because the goal is to not just long divide this thing. That's tedious and annoying. So, is it divisible by 2? It's going to be yes or no. Silence is not one of the options.
Maybe
No, it is
no.
not.
No.
And then a little reason here, because the most digit is not 0, 2, 4, 6, or 8. Something like that. Some little short little description why you're saying that. In order for me to answer the 3 question, I would have to find the sum of the digits. And in this case, it is 5 plus 4 is 9, plus 7 is 16, plus 3 is, 19. So close. Almost a good guess. And we could say here 19 is not divisible by 3, and therefore the original number is not divisible by 3. So I indicate that I do understand that the test involves the sum of the digits being divisible by 3 in order to be a yes. That fails, so it's a no. So every number is potentially going to have a different test. Some substantially different, some like 9 is going to be very similar to this one, but it is a new test. I should have made this more interesting. Oh well, it was random. Uh, just like the test would be. For 4, maybe we get a yes somewhere. I don't know. For 4, it's going to be a no as well because the well, what was that right in there? The rightmost 2-digit number, I'll say, is 3. I'll say 0, 3. Maybe that was a terrible example. And that is not divisible by 4. 5, completely different test. I'm going to get all no's, aren't I? Rightmost digit is not 0 or 5 that it's allowed to be. Then 6 is going to be a no as well because the number is not divisible by 2 and it's not divisible by 3 either. I needed both for 6 to be a yes. 8, well, let's check. The rightmost 3-digit number that I sort of extract is 703, and that is very much not divisible by 8. How do I know? No multiple of 8 ends in a 3, so I don't even have to bother. It's going to have to end in a 6, an 8, a 4, a 2, a 0. Can't be a 3. And then I would have to check further. 9, sum of the digits, 19. That's going to be a no. Sum of the digits is 19. 19, not divisible by 9. 10, that'll be another no. The rightmost digit. So whether it's a yes or a no, I still have to explain how it's compared with the divisibility test. So it doesn't really matter if it's yes or no. For the test for 11, I'm going to have to calculate, I called it something recently, not in the video, just my comparison number that I'm looking. It's not the sum of the digits, it's a different calculation, but some comparison number. Sorry, that wasn't very clearly written. Let's try again. Comparison number. I just have to call it something. I like to go right to left. 3, because that one's digit will always be positive. Minus 0 plus 7 minus 4 plus 5. I get 3 plus 7 is 10. Minus 4 is 6. Whoa, hello. Can it be? We weren't completely unlucky. Do I double check this? I'm paranoid. 3 plus 7 is 10. 6. 11. Yeah, wow. Yay. That is divisible by 11. Oh, so we weren't completely unlucky. Subconsciously, I made a good example. Good job, me. So regardless of yes or no, I like to have a better mix of yeses and nos, but it doesn't really matter. I have to show my knowledge of the divisibility test either way. How do we feel about this very typical question?
So you pretty much just like go through like all the rules and just like test it out?
Based on this question, it's asking me for literally all of them.
Okay.
Now, a quiz question might not necessarily ask for all of them, right? It
Okay.
might make your life a little bit easier, or it could ask for both. It depends. It depends. I will never say that it's divisible by 2, yes or no, because it's an even number. You can't define something by itself. I'm sure I said that in the video. A number is called even if it's divisible by 2. I can't say it's divisible by 2 because it's even. That's backwards. It's like saying a dog is a dog because it's a dog. That's not an explanation. You're just sort of looping back on yourself. It's a comparison of the rightmost digit. And if that's a yes, we then call that number even. You can't use a later definition to define an earlier concept. Technicality, sure. Some people look at me like, what are you saying? But it is correct. A more typical question here could be, before we move on, to have a little bit more fun with this. There's nothing wrong with the previous question, but to have a little bit more fun, we could say something like, um, let's see. Let's say 3,700, missing digit, and 2. I want that to be divisible by, I'm going to, let's say 3. What is the missing digit? See, that's a little bit more fun, though it still just relies on my divisibility tests. Now I'm just going to change this a little bit and take this example and go through all of them. So instead of having just 1, I am going to have a part A and then say here by 3, then by all the other numbers. So we can see the different ways we look at this. Maybe not every single one, because 9 would be very similar. So I'm going to call this missing digit X, just so I can name it and work with it a little bit. So now for the divisibility test, for divisibility by 3, I know the test needs to look at the sum of the digits. And in this case, the sum of the digits will be 3, 7, the X digit, and the 2. So that would give me a 12 plus that mystery digit. So that means this must be divisible by 3. Now, what are the options for X to make that statement true? 0, because then 12 is divisible by 3. Or 3, the digit could be 3, getting me to 15, which would be divisible by 3, which would make the original number divisible by 3. Or a 6, getting me to 18, which is divisible by 3. Or a 9, getting me to 21, which is divisible by 3. So I actually have a bunch of options for the digit that could be in that place. For example, 3,702 would be divisible by 3, 3,732, 3,762, 3,792. It's a little bit more fun question, but still based on the same thing. Divisibility test for 3 in this case, for example. Let's try 4. Divisibility by 4. Now I'm not looking at the sum of the digits. I'm looking at, let's suppose here, let's call it my comparison number. Can I not write? My comparison number is now the 2-digit number with a mystery tens digit and a 2, something 2. 32, 22, 42, who knows? That must be divisible by 4. So what are my options? My options are, I know my multiples of 4, so my options are 1 for 12, not 22, 32 would work. 32 is divisible by 4, not 42, 52. I'm doing a lot of work here. You should do something. 52? Can X be 5? No, silence. Am I making any kind of sense here? I wonder if my microphone
You're
is...
sort of cutting out on my end.
Oh, why? I have 3 green bars.
Oh, now it's back. I don't know. I just noticed at the beginning too it did that, but then like it's fine now, so
Oh,
hopefully it's okay.
well, let me know if it
Now I
happens
can
again.
hear you.
Oh, maybe my finger slipped. Should I go back to something?
maybe like I didn't hear like about like the 3 like when you added it. Maybe like just start from there and then go on.
This little last 3, this guy?
Yeah.
Oh, okay. All right, so I'm looking for the tens digit in this number so that it's divisible by 4. 12 would be divisible by 4, and therefore the tens digit x can be 1. 32 would also be divisible, so x could also be a 3. And then 42 would not be divisible by 4. So the next one should test is 52. Would 52 work?
Yeah, I think so.
Yeah, 52
We
would
divide by
work.
13.
So 5 would work for the missing digit. And then 62, no. 62 is not divisible by 4. 72 would work. 82, you can check, you can do a little division on the side here. 4 goes into 8 2 times. 2 times 4 is 8. It's really 80 minus 2. Oh, no, I can't. It's a remainder. That's not going to work, but you can test 9 will work again. So here are all my options. If I'm looking for the mystery digit so that the original number is divisible by 4. And you can pick others. Maybe 11 is interesting. Let's maybe make a C11, and you can easily make these up yourself, right? And then verify them with your calculator. Super easy. There's no limit, and you can put some on the course chat and see if someone verifies your answers, whatever you want to do. For 11, my comparison number that I should be looking at, what were the digits? 3, 7, something, 2. Right to left, 2 minus x plus 7 minus 3. Simplify that to get me to 2 plus 7 is 9, minus 3 is 6, minus x. That has to be divisible by 11. 11 is a little different, though it has a similar strategy to the sum of the digits. All right, so now my options here, sort of guess and check. Options for x are 0. No, because then this comparison number is 6. 6 isn't divisible by 11. 1, 2, 3. Which x will work? Will any x work? Any value for x?
I don't think so.
There is one. It's a technicality. It is 6. Then my comparison number. Then the comparison number is 0. And 0 is technically divisible by 11. 0 is divisible by everything. That's not 0 itself, of course. Based on the definition of divisibility, there is this little exception, and 0 is a special number. And it doesn't always seemingly follow the same rules. Technically, it follows the same rules. Intuitively, not always. So that's the one, especially in the test for 11. Because I'm adding and subtracting to get my comparison number, 0 is a possibility, and that's going to give me a yes. So it's only something I need to be aware of in the case of 11. This question is a little more interesting, but it's the same kind of question, right? Any thoughts so far? We can come back to it. Oh, I hear a beep. Someone has something to say. No?
I was just gonna say like it makes more sense now.
Yeah, it's just mixing it up, practicing a little bit, being very aware of what the test is for each number. That is the key thing here. Uh, you can't mix it up. Every number has its own test. So then going through the list here, that was a 9.4. And they're all, apart from checking if you can do long division, the problem 9.6, it's all just variations on that right now. Um, Having one missing digit, like we just illustrated, is a very manageable question. You'll see that when you try 9.9, 9.10, it's a big step up, having two digits missing. So you just have to go slowly and list all the possibilities, and systematically you'll reduce it to options that will satisfy all the requirements. But they definitely require a lot more work. Um, just because my preview seems to do weird things, can everyone still see the video?
It disappeared for like a minute, but now it's back. So
Yeah, I'm not sure why, but I can't see my preview. Anyway, we'll keep going forward. Let me know if anything is weird for a significant portion of time. 10.1, 10.4. Yeah, 10.4 is almost more concept than anything else. Let's do 10.1 first. So we have a very specific method to figure out if a number is prime or not. Very specific. And a question people, I always feel bad because people answer this question in not clear ways at all. And technically, I should subtract way more in the quiz, which I probably will, since you have a book. We have to show that when we test a number, should we just make it up? Or should we use these? Just gonna make it up. For my first one, I'll just make it up, and we'll come up with a nicer one in a second if this one happens to randomly not be good. Let's go with 1,021. Sure, let's go with 1,021. Why not? So, in order to figure out if it's a prime number, I'm checking divisibility, but not just everything. That's an immense amount of work, completely unnecessary. If I understand what the sieve of Eratosthenes allows me to do, I'm only testing divisibility by prime numbers 2, 3, 5, 7, 11, 13, up to a point, p, up to a prime number p. And that's going to be my last one I need to check, where p is the largest prime number, so that, e, it's an e, can I not write an e? Let's try again. Largest prime number such that p squared is still under my target number. So now maybe some trial and error requires that I check how far I need to go in this list. Sure. Now you could also rephrase this. Some people like this, not everyone does, to take the square root of this number, and then your p stopping prime number has to be less than or equal to that. So let's see, what is the square root of 1,021? Whoops, accidental W. All right, so MathBot says square root of 1,021 is 31 and a bit. So this is going to be 31 or below. Now, is 31 a prime number? Now remember, this is an open book test, so you could just easily Google this. It's super easy. But which makes the work that you show so much more important. You can't say yes or no because Google said so. But on the way, you can certainly look up, is 39 is 31 a prime number? Is that my stopping point, or am I stopping at a 29 or something? What is my list going to be? Now I'm going to run out of space here. Let's continue the list over here. So after 13, the next prime number is... You guys are way too quiet. You need to be interacting. I'm going to ask more and more questions until people say more and more things.
17.
17. And then we go to 19, 23. After 23,
29.
29 is 31 something I should include. I just need to not go over 31. I could be at 31 if that's a prime number. Yes or no? Maybe. Sometimes. I guess so. No response whatsoever.
Sorry, could you say that again? You cut
Should
out.
I include 31? Is 31 a
Yeah.
prime number? Yes, it is. So that is where I'm going to stop. I don't test things that aren't prime numbers. I only test prime numbers. That is the efficient way to decide if this 1021 is a prime number or not. So now I check. Divisibility by 2? No. But that's a good thing, I suppose. I don't want things to be divisible. I want to get, yes, it's a prime number, which means I need to have a no divisibility on all of these guys before I can say for sure. Divisibility by 3. Now, some of these I have divisibility tests for, some of them I do not. So calculator is fine here. 3, by the time you punch it in your calculator, I've already decided it's a no because the sum of the digits is so easy. Then I continue. Divisible by 5? No. 7, well, 7's not the nicest thing ever, but I want to say no, but let's double check. Because doing the divisibility test for 7 in your head is not very efficient, but it is in fact a no, so you can use your calculator to confirm, of course. You still need to show the work. Calculator can definitely help. 11, it's easy enough. 1 minus 2 plus 1. Ooh, it's a yes. How do I know that's a yes? I didn't calculate it. Of course, you can verify.
Because it equals 0?
Because it equals 0, and that's the special one. And then you can go to your calculator and verify for your peace of mind for sure. Did I not do that right? 1. Did I not type something in right? Huh?
Because it would be plus 0 and then minus 1? 1 minus 2 plus 0
Oh,
minus
I
1?
just did it way too fast, didn't I? 1 is a plus. That's a minus. That's a plus. That's a minus. Oh, I was just excited to find something. That's not right. But I've illustrated something on purpose, of course. That's very important. That you can use your calculator to verify your divisibility test that you sometimes need to explain or you may want to do. I was really wanting something to be a yes. I did the test too fast, of course on purpose. I would never make a mistake. And then I go to my calculator to verify. Oh, no. Double check. Oh, I didn't do the test right. Okay, fine. That's a no. Let's continue. So have these things as backups. It's totally fine. Totally fine. Then After 11, I don't care to memorize divisibility tests. They're not really time savers anymore. So we are going to be more and more reliant as the numbers get bigger on our calculator. Divided by 13. So that's a no as well. I don't actually know. This feels prime to me, but that's not, I can't just base on my feelings. There could be something that I'm not seeing as factors because these numbers aren't that familiar to me in terms of their multiples and stuff. So I check 17. That's a no. 19. I'm beginning to think this is a prime number, but we have to go all the way to check. I'm sure I did in the video the example, which we can maybe do a similar one, that shows that you're going to have to go all the way to the end because that last one could be the one and you don't know. Let's check 23. I'm hoping for one to show up, but I am doubtful. You never know. 29. No, not yet, but there's one more. All our hopes rest on 31. You are our last hope. To make sure I actually type it in right. Oh, so close. Actually, not close at all. That is a prime number, which of course you can go to Google and verify. Is it in the list of prime numbers? So having it be open book, you always have a way to verify, right? But you have to show that you understand to test only prime numbers and up to which point. Those two things are very important. And I see people all the time, all the time. They understand they have to test divisibility. They just think, oh, I should stop at 11 because that's the only divisibility tests I know. So I'll just stop there. And if those don't work, that's prime number. No! It's got nothing to do with that. Those are just for convenience. You could use your calculator for 2 if you want to. Doesn't matter. It's completely irrelevant. If you can quickly do a divisibility test, it's just efficient. That's the only reason it's there. So that is a problem like 10.1. And as soon as you find one that's a yes for divisibility, then you stop, right? You just need to know if there are factors. Doesn't matter how many or anything like that. All right, progress. Please let me know if you can't quite hear what I'm saying. I can't tell if that is actually happening. But we move on. What was the other one? I have so much MathBot in my chat now. 10.4. 10.4. 10.4. Let's just think. Before we do 10.4, it would make way more sense if way more sense if we do all the other questions first, I would say. So let's do a prime factorization one, and then greatest common factor. Then we can come back to 10.4. Make way more sense. Not that we have to. Now, I don't want to randomly make a prime factorization one because that's not always going to be as nice as we want. So let me make something that's going to be nice for us. Hold on. Okay, let's do the following. Maybe a little big, but I think we can handle it. 2,646. I should have probably written it in the middle, shouldn't I? Yeah. Whoops. 2,646. Now, when you do a factor tree, your tree, of course, might look different than mine. It's all depending on which one you see first. And if you pick two factors that are sort of the same size, your tree is just going to look a little bit more balanced. If I pick a 2, which obviously divides into that, then my tree is going to be a little longer and unbalanced. Doesn't make it right, doesn't make it wrong. It's just different trees getting me to the same result. So, which factor do you want? Don't spend too long looking for something a little bit more interesting. If it's not there, it's not there. But I could maybe add up the digits, and I see then I get an 18. So that would make it divisible by 9. I'm not going to spend too much time on finding two factors that are each in the tens or hundreds. It's unnecessary effort. So let's find the other factor. 2646 divided by 9. It is 294. Oh, 294. Wasn't there an example like that? What's this line doing here? Be gone, line. We don't want your kind here. All right, everyone with me. It's very quiet. It's making me uncomfortable. It's making me think my mic is broken or something.
We're tracking.
All right, good. Now, oops, I'm in eraser mode. One side of this is super easy. I strongly recommend, especially when you're teaching this, and you might, factor trees. Maybe grade 4, maybe, could be. Certainly 5, if not 4. Put circles around your endpoints. As soon as you get a prime number, put a circle around it. Because if this is a bigger tree, little Timmy's going to forget that this was one of the 3s he should be including, especially if it's a little unbalanced. So now I won't miss these 3s after I am done with the 249. 294, not 49. 294. Let's pick some factors.
3.
3. And then 3 goes into that. How many times? Let me show it in chat. I mean, I don't need to, but it's good to do it in your head. But then there's something to see. It's not a bad idea. 98. 98? Right. Okay. So then I split 98 further. 98. That's weird. That's 49 times 2. All right. And 49 is 7 and 7. And I have completed all the branches in my tree. And then I can say, I like to do it in order. So 2 times 3 to the power of 3 times 7 squared. And there you go, prime factorization. But what does this actually mean? If I have the prime factorization, if I've split the number into its building blocks, I technically now know all the divisors of this number. All the factors, not divisors, factors. Anything that's made up of 2, 3s, and 7s. Those are the only contenders for factors here. So I could make some random factors. I'm not going to make them all. There's a lot of them. I could have 2 and maybe a couple of 3s. That's going to be a factor because it fits in the building blocks of my number. That's one of them. I could have maybe a couple of 3s and a 7 because it fits. I can't have a couple of 3s and 3 7s. that doesn't fit anymore. I only have room for 2 sevens. I can go 0 sevens, oops, eraser, or 1 or 2, but I can't go above that. And of course I can mix it up to all three of them. Maybe a 2, 2 I said. Then maybe a couple of 3s and maybe a 7. So by seeing the building blocks, I know all the factors. Just all the combinations of what I'm allowed to do so that they still fit in. Is everyone happy with that? Because we need that in 10.4. I'm very insecure. I need constant verbal confirmation that I'm doing a good job. You can tell my insecurity if you look at the YouTube videos because I hide behind a polar bear face. So I need constant validation. Good job. Keep going. You can do it.
You wrote those two middle factors, they're the same. Or,
Yeah, it's because I had a 3 here, right? Which would be
all right.
bad. They could be the same. They're still valid. And if I have too much of any building block, then that's not a factor. All right. So now if I look at 10.4, let's move it up a little bit. I'm given a number. It's already sort of broken up for me. Is 67 a prime number? I guess it is. Really? Yeah, I guess so. So sometimes they trick me and they've given almost all of the tree, right? The tree will end in 9 2s, 3 17s, and 2 67s. It's just good to check. Can I split any of these further? No, they're all prime. Okay, that is the actual end. So now, without any calculation whatsoever, I know what the factors are of this M number. They have to fit into the building blocks I have available. So is number 1 a factor or not?
No, because there's no 7.
There's no 7. I can't just make up building blocks. I'm restricted to 2s, 17s, and 67s. And I know how many. 7's not one of them, so no. Number 2, is that a factor? I do have the right building blocks, but I have way too many well, not way. I have too many 2s. I'm only allowed 9 2s. Can't do any more. So 10, it's not going to fit. It's not going to divide. I casually sort of think of this intuitively as fitting the contender into the number, but it's all division really when I say fitting. Division with no remainder. Number 3, can that fit in? Yeah, that's perfect. I have room for 8 2s, I have room for 2 17s, I have exactly room for 2 67s. Perfect. Number 4, sort of. Can I write on this? I'm not sure if I can. No, it's not going to look good. 34 cubed. 34 cubed. So now my number needs a little bit of splitting up. So this is 34, 34, 34. 34 is not a prime number. That's 2 times 17, 2 times 17, 2 times 17, which makes this number that I'm trying to investigate 2 cubed times 17 cubed. Now there was a shortcut, but you don't need it. This is short enough. So the number I'm really comparing has 3 2s and 3 17s. Yeah, that's fine. That can fit. No problem. So I might need to work on this a little bit, especially like number 5 as well. 134. What is that? 134. And there are 2 of them. So from something higher up, I get that.
You're breaking up
Oh,
again, and then
why?
your screen is sort of frozen. Okay, now,
Double
but like, yeah.
double check. Maybe the YouTube if you go to MathCats, there's a stream of the same video on YouTube. Maybe that has less of an issue. I don't see anything on my end. All the bars are green and full. It's really hard to know.
Yeah, it's weird. I'm getting the same though. Like you break up and then the screen completely freezes.
Yeah, it's so weird.
Yeah.
I can't really. If I check my own stream, it's going to slow it down more. So
Okay.
if someone who knows what they're doing can go to YouTube and check if that stream is maybe better, because YouTube has buffers and stuff like that, right? Uh, to have the YouTube is delayed by 2 seconds so that it can buffer and do all its fancy things. To have the YouTube is delayed by 2 seconds. Oh, that was my own voice. You're gonna have to mute one of them. I was like, who is that? He sounds amazing. Um, whereas Discord, the audio is pretty much real time, and because of that, there's no buffer, and if something goes wrong, you're just sort of seeing gaps. So be aware of that. Uh, for some reason, today is not a lag-free day. And the 2 second delay is really not that bad at all. That's the best I can do. So we have 134. Huh. That is certainly not prime. And if I can't see anything, which I can't, I can certainly take a 2 out. And then I have 13 divided by 6. No, 13 divided by 2 is 6, leaving 1, 14, 7. So I didn't need to split this up a lot. They're all prime. So the number that I'm really checking is 2 squared, 67 squared. And easy. I have enough room for those components. Not a problem. So yeah. The YouTube stream is better anyway. It has some production. You can finally see the polar bear. It's good times. And the chat is still there, but I can't have those things in Discord. I can just share my screen. Any thoughts or questions about technical issues or the example or anything like that? People, I feel, just rush towards a question like 10.4 before really understanding what the visibility means when I'm looking at a prime factorization. And I can just compare sort of things fitting into other things in an intuitive, more intuitive sense. A number sense, if you will.
Yeah, for like 10.4, like I felt like I understood the first three ones, but then once it got to like the 34 and like 3, I was sort of confused on what to do. But
Right,
now it
right.
makes more sense.
Yeah.
It was like prime.
When I do it this way, everything has to be prime numbers. I can't have a 34 floating around. That's just going to be confusing. They need to all be broken down. My original number and the number that I'm uh, examining whether it's a factor or not. So they're trying to trick me by having some parts of it not broken up. Especially this could be, for example, if this was a 64 squared, then this isn't finished. I need to finish that 64 to see the actual prime factorization. And that's something people miss very quickly or very easily.
Stephen, when you say explain how you know, how would we explain that?
You could just say in a brief sentence that the prime factors in the, let's call this the number that you're trying to fit, the what should I call it, the given number, the prime factors are the same as the prime factorization of my m, and there are fewer of them in this product than there are in my m number. So just a brief sentence is fine. You can very easily tell from a sentence like that whether or not the person understands what they're doing and didn't just guess or calculate it. So again, a sentence like that, do think of it in advance, but it's there to verify that you understand the concept, because a calculator can do all of this and I can test divisibility by just multiplying this out, seeing what m is, multiplying the contender out, seeing what that is, and just doing a division. That's not the point. The point is to have this, to test this number sense of numbers fitting into other numbers by division and multiplication. That is, sure, in elementary school, maybe your numbers are smaller, but the number sense doesn't change. And that is the most important thing that we're trying to get out of this. We're just making it bigger because, yeah, we want a little bit of a challenge at least. The concept doesn't change. That was 10. Where's 11? What is 11? Oh, 11 is easy. We did some of it. We can do some of it. Oh, we need two numbers, don't we? We have some of it. We can use this guy. And let's just make another one as if we've done the tree. Let's just make another one and say some other number. Who cares what it is? I get maybe 3 squared, and maybe I get a 7, and maybe I get a couple of 11s. Let's suppose these are my two numbers. Let's call this A, let's call this B. Just for convenience, I don't know the other number. We can then say greatest common factor of these two numbers and least common multiple of these two numbers. Greatest common factor first. So now again, this fitting in concept is the key. I am looking for a factor. So my answer that I'm constructing has to fit into either one of these numbers. That means I'm restricted to 2s, 3s, 7s, and 11s. It has to fit into both. It has to be common. That means I can't really use a 2 because a 2 will fit potentially, if I don't use many, into B. Well, it's not going to fit into A. It's not going to fit into A. So I'm kind of restricted to 3s and 7s, it looks like. Otherwise, it won't fit into both. And now I'm just trying to make the biggest one possible. So how many 3s can I get away with while still fitting in? That was a question. This is awkward. How many 3s? Am I breaking up again? How many 3s? Am I breaking up again? How many 3s? There's a delay on YouTube, so I'll allow 2 seconds for you to think. How many 3s? Right there, right there. Whoop.
Is it 3?
It is unfortunately not, but I do appreciate you saying something. It makes me feel much better. Why is it not 3? Whoopsie. Why is it not 3? That's the question. It's totally fine to say the wrong thing, as long as we learn from it. We're looking for factors. Factors fit into A and B.
We don't have enough in A.
We don't have enough 3s in A to accommodate 3 3s. It's not going to fit into A, and it needs to fit into both. So for that reason, the highest we can go is a 2. 2 3s. Then it'll fit in both. 3, too much. Whereas for 7, I'm gonna be stuck with 1. If I do 2 7s, they won't fit into A anymore. So A seems to be the guy that is a little restrictive here. Now, when we get to the least common multiple, the situation's kind of flipped around. I'm looking for multiples. So that means it's now reversed. That the A and B number need to fit into my multiple. The answer that I'm making here, A and B need to fit into that. So in order for A and B to fit both individually, I'm going to have to see some 2s, some 3s, some 7s, some 11s. A needs 3s, 7s, and 11s. B needs 2s, 3s, and 7s. So I'm going to have them all in there to make them both happy at some stage. Common. But I want to make it as small as possible. How many 2s can I get away with?
1.
1. Just note that if you're watching on YouTube, I do not see the chat there. You're going to have to still chat in Discord. Just FYI while I'm thinking of it. I am not checking the YouTube chat. 1, 2. 3s? I want to make it as small as possible. But if I don't allow 3, B won't fit. So it's the lowest I can go. 7? Yeah, I'm going to have to go 2. Or B again won't fit. A says, yeah, I'm fine with 1, 7. No big deal. But B needs both. And 11, no. A says, I need 2 11s. Or I am not going to fit, and I'm going to be a very grumpy A. And there we go. Questions on GCF LCM?
Can we maybe go over another example? I'm still a bit confused.
Sure. Now, are you okay with skipping the factor tree and just starting with the prime
Yeah,
factorization? Okay.
I understand like factor trees. It's just like doing the other stuff.
Yeah, so that will just make our lives easier if we skip the tedious factor tree, and then I don't care what I make up really. It's easier. All right, so let's call the two numbers. Let's say maybe a few 2s and maybe a 5, maybe a couple of 5s and maybe a 7. There's no need to make these big. Let's maybe make a 2, maybe a whole bunch of 3s and some 7s and maybe an 11. All right, there it is. Now perhaps it's beneficial to maybe take a minute or so just to see if you had to, what would you come up with? We have time. Why not? Let's take some time. All right, we're back. All right, GCF of these two numbers will be, well, now I have to think. And I strongly recommend not thinking of a formula or something like that, but rather understanding what does GCF require? There are three letters. They each require something. Well, factors. Okay, so the number I'm making right now needs to fit into A and it needs to fit into B. Okay, because it's common. So in order to fit into A and B, I'm going to have 2, 5, and 7 to fit into A. To fit into B, I'm going to have 2s, 3s, 7s, and 11s. Needs to fit into both. Okay. And I want to make them as big as possible while still fitting into both. So that's not right at all. Why is that not right? Everyone's just going along with what I'm saying.
Isn't that what it should be for a lowest common multiple?
Yes, to be a factor, I can't have a 3 because it won't fit into A then. I can't have an 11. It won't fit into A. A is the picky one, it seems. Oh, I can't have a 5 either, can I? Because B has no 5s in them. So if I'm looking at a number that has any 5s in them, it's not going to fit into B. So the only common prime numbers in A and B are 2s and 7s. So, okay, let's sort of bracket that and make a cleaner answer. But it's very important to understand why are some in here and why not others. Now I'm trying to make the biggest one that can fit into both. How many 2s can I include in this answer? Only one. Even YouTube is lagging? I can't type. Yeah, if YouTube is lagging, then we are without hope. So let me know if I need to repeat anything. Only 1, 2. Only 1, 2. Because otherwise, if I have more than that, then I won't fit into B anymore. How many 7s can I have? Yeah, only 1 7 as well. Oh, that's unfortunate. But it's the best we can do. It's the best we can do. Now LCM of these two numbers. That's a different situation. There I'm looking at making a number that both A and B can fit into. So in order for A to fit, now I'm going to have to see 2s, 5s, and 7s. In order for B to fit, I'm going to have to see 2s, 3s, 7s, and 11s. Any one of those missing, one of these guys will not fit. Multiple, common, but I want to make it as small as possible. So what is the smallest number of 2s I can have while still making A and B happy? 3. Any fewer, A won't fit. How many 3s? Well, 4, because B only cares about 3s. How many 5s? Well, 2, because A is the only one caring about 5s. So I need to make them happy. 7s? I'm going to have to go 3, because any fewer and B won't fit. And 11, just the 1. I don't care to calculate that number. It's irrelevant. It's the thought process, the number sense behind it. That is where the value is. I could not care less what that answer is in its final numerical form. All right, hopefully that didn't lag too much. There's really nothing I can do but restart my computer maybe, but there's no time for that. So hopefully, well, we don't have anything tomorrow, right? Are there any questions about how proceedings will go tomorrow? It is in the course chat. What is happening? I'll post it in Discord, the test papers, as well as email it to everyone. So there are two places you can find it. I'll send them out a little bit before 4 o'clock, like a few minutes. And you have an hour per quiz to split up as you want. And overall, there is another half hour to handle printing and scanning and all kinds of things, whatever you want to do. I don't have a printer. You don't need to have a printer. You can, if that's the case, just write your answers on blank paper, number them, maybe scan them in order. That'd be nice. I'm amazed at the kind of answers I get. Just random arrangement of answers that makes it so difficult. Which do you find works better, writing on the paper themselves or writing on a separate sheet? The paper themselves will always be better. But don't go out hunting for a printer if you don't have one. I don't have one. Lined paper is fine. Do you want both tests in one PDF file? Here is the thing. Now, I want to check if I put this in the course chat pinned message. Let me go there. Regardless of how you send it back to me, email, hopefully something I can open, I can grade it if I can read it. But if each quiz is not a single PDF file, then I can't put it up graded on the website for you to see, which means you can't really question what I did or how I graded it. You can't see it. You can't know anything but your final score. So it's totally up to you. Send it as individual photos. I'll still grade it, but I'm not going to be able to get it back to you graded. Send each quiz as a single PDF, and then I can grade it, give it back to you on the website. Right at the top where your percentage is, there will be a link. You can view it. Everyone is happy. So that's the thing. So it's not like you have to do something, but some submission methods are better than others.
Okay, sorry. Like it was like lagging, so just to make sure, like it's best
Yeah.
to send it as one file, like quiz 1 and 2 together.
No, each quiz its own single PDF.
Okay, sorry. It was just like lagging.
No, it's totally fine. Totally, don't even worry about it. It's all good.
Okay.
And again, if you happen to send everything as one PDF, totally fine. I'll grade it, no problem. Your grade isn't compromised. It's just a matter of do you want to see the graded paper or not. That's the only thing. It's just an administration issue. That if I had to separate and convert and merge and group everyone and make them in the way that I can put it on the website, it'll literally take weeks. It's so annoying. So it's only there for administrative reasons. Your grade will still, if I can read it, I'll grade it. If it's a picture or a scribble or something, either way I can grade it. It's just I can't necessarily give it back to you.
And then also just to check, so we have to it has to be emailed by 6:30 because it starts at 4.
6:30, yes.
Okay.
6:30. So do check, pretend you're writing a test, and scribble something on a piece of paper. Uh, See how you're going to scan it. See how you're going to email it. Email it to yourself as a test. All these things should be done before the actual test, because you can do a sort of a mock test run with all the technical side figured out. Because the only timestamp that I get is on my email, and if it says received 6:31, then that is technically late, and I have to subtract a little something. I'll still grade it, but the later it is, the more I have to subtract, because it's not fair, right? What if that extra minute you actually were writing something and it gave you an advantage? It's not fair. So do check, how fast can I scan these things? How much time do I need to get that email in safely under the time? Half an hour should be more than enough if you've prepared.
Sorry, Stephen, for 9, 10, and 11, how many questions can we, or is it going to be similar to the first quiz where you do like
Oh,
a part A and a part B?
there will be, but they each have their own page. Let me double check.
Okay.
Oh, I went too far. There we go. So page 1, actually it's a chapter a page. Chapter 9 has a page with probably an A and a B at least. Chapter 10 has a page. Chapter 11 has a page. Oh yeah. And then we haven't gotten to the rest yet. But they will each have a page as well. So it's broken up fairly well. Let me just, before I forget. Oh no, that was with fractions. Never mind. No.
Sorry, Stephen. Quiz 2 is the numeration systems up
Yes.
to
Chapter
okay.
7. So it is Roman conversions, Babylonian
Roman.
conversions, Roman Babylonian arithmetic, then other bases conversion, other bases arithmetic.
Okay.
Yes. And we've done, if we haven't been able to get to all the questions, check the other previous live streams. We've done stuff there. We can't always do everything in this session, perhaps. But if you wanted to go further back, we did
Yeah, that's
those
fine.
things Tuesday, Monday.
Yeah.
So check those videos. I put them at the end of the playlist. I'm
Okay.
just saying in general while I'm thinking of this. I'll double check if I have to wait a little bit so that YouTube can process and everything before I can add it to the playlist, but I will double check if Tuesday's one was in fact, if it's already on the playlist.
Okay.
I will add
And then
it. Yeah.
after that, then for Monday, it's chapter 12, right?
That's a good question.
I'll
Let's
have
go.
to. It's okay. I don't think I printed it. It's fine. I can look that up. Thanks.
I am looking already. 12 and 13. Oh, that's a short one. Oh,
Okay.
wow. Feel free to go faster if you have the time. 12 and 13, really? Wow, I was very generous. 12 and 13. I don't think that's gonna take you that long. So maybe we can dip into some fraction action. At least in part. So feel free to go ahead into fractions, because that's the big chapter that you may need more time with. So the faster, the better head start you can get, the more of a head start, the better. Yeah. So don't feel like you have to stick to that schedule on the website. That was just a very rough guide to get us to the end. So we don't have to stick to, oh, we can only talk about chapter 14 on Tuesday. No, you could do it earlier on Monday if you want to. If you find 12 and 13 easy, especially coming over a weekend, I think you should maybe make some progress into chapter 14. I'll edit that. I'll make it 12 to 14 and then 14 on Tuesday again. That'll be better. Yeah. How many questions are there per page? That will be a mystery. You will see tomorrow. Maybe one, maybe many. Who knows? Well, I know, but I'm not saying. Can the assignments be done the same way as the tests, like on paper, or we're only allowed to complete them by editing the PDF? No, if you're having a lot of trouble editing the PDF, it just doesn't seem to work for you, totally just do it on a separate paper, as long as you're doing it, right? The whole point is to sort of do a check. Can I do these worksheets and can I do them with ease? Where you write the answers, what does that matter? The size of the Sudoku was 6 by 6. Yeah, we won't go further than that. There's no benefit. We'll just lose a lot of time. I don't see any point. But Karuji could be up to 4 by 4. 3 by 3 Karuji is very limited in what we can really do there. We have to show a couple of letters and then suddenly there isn't much space to do anything. So you want to be ready for that. And I did attach a little PDF that I found randomly that you can look for extra practice, but you don't have to. Yes. Any other thoughts? It's very quiet. Is that because this is going to be too easy? I know.
How soon will you get our quiz midterm back to us?
I'd like to do it quickly and just sort of be done with it from my point of view. And there aren't that many of you, so it doesn't really drag on. I mean, the last semester I had like 80 something for this course, and oh, it just went on forever. Then you sort of it's soul crushing work grading that many, but for us it'll go very quickly. Sometimes Saturday, yeah. There's no need to delay. And then if you've submitted it correctly, not in the ideal way as a single PDF per quiz, you'll be able to see it on the website and uh, see what happened. It's always good to double check. And I'll, of course, upload the solutions and all those things. Yeah.
Okay. I guess my last question was, you've got two email addresses, or at least I
Do
have
I?
two.
Oh,
Or
I'll get
maybe I
them.
put in.
I'll get
Yeah.
them both, but the math one,
Okay. All right.
the one that says .math, is really
Okay.
only there to group things a little bit, separate things, and I don't lose them as easily. But
Okay,
I'll
thanks.
get it either way. Yeah.
Okay, thanks.
Your point of view that you haven't done one of my tests, so you don't really know. It's so nerve-wracking. But there's more than enough time, honestly. The hour per quiz, especially being open book, that if you've prepared correctly, that should be more than enough time. More than enough time to sort of balance out any possible technicalities that might come up. I wouldn't worry about the time as much. There certainly isn't time to, oh, here's a Lady in the Tiger question. Let's look up how that works. No, of course, there's no time for that. You're going to have to go in knowing something. But if you do, the time really shouldn't be an issue based on what I've seen in the past. So there's not much to worry about. We're in Discord. I'll keep an eye on it if you have any questions. We're not going to be in voice chat, of course, because how would I control your chatting with each other? But I'll still keep an eye on the chat if you have any questions. Yeah, I wouldn't worry about it. All right. Any last words since it's getting quiet and I'm feeling lonely? Again, I will go and double check right now after this to see if all the sessions we did, except the very first one, is at the end of our playlist, so it's easy to find. We've done all the examples pretty much that is aimed at the quiz, so there shouldn't be much mystery there. And let me know if you want more mystery going into next Friday. If you feel this was too straightforward and predictable, I can certainly go the other way as well. It's your course. You tell me what you want. Um, I would say it's hard for me to be objective and unbiased, but if you're going to take a test for the first time almost, this isn't a bad one. It's not a cruel test. It's not a race against time test. It's just I just need to verify that you know what we talked about. You'll see when you get it. Uh, you'll see nothing there is unpredictable. It's actually too predictable. Maybe I should change it. Uh, Let me know for the next one. Maybe it's too predictable. But it's not a bad re-entry quiz to get you into the swing of things again. But you can let me know, like, you told me I shouldn't be nervous. This was terrible. You can let me know either way, good or bad. All feedback, if it's constructive, all feedback is appreciated and valuable. You'll see it's going to be very predictable. So the only room I really have to, the only wiggle room I have is in page 4 on the other puzzles. There's some variety there in quiz 1. Past that, there's no variety really. Maybe page 5 as well. Maybe. Not that much though. Yeah. Anyway, yeah, I'm just rambling. Feel free to keep chatting, but I'll end the video before people actually fall asleep.